All right, let's talk about one of the biggest puzzles in blockchain. How do you get ridiculously fast without completely breaking security? Well, the answer might just be this really cool concept called the K-cluster. So let's dive in and see how it works.
To really get why this is such a big deal, you just have to look at the numbers. On one hand, you've got Bitcoin, chugging along at one block every 10 minutes. And on the other hand, you have systems that are cranking out 10 or even more blocks every single second. It's a completely different universe of speed. But that speed brings up a huge problem. I mean, when you have blocks popping up all over the world, all at the same time, how on earth does the network agree on what's real? How do you stop it from turning into total chaos? That's the billion-dollar question.
And this, right here, is where the K-cluster steps in. It's a really elegant way to solve this exact security puzzle, built for a world where blocks are happening in parallel. So what exactly is a K-cluster? Well, the simplest way to think about it is that it's a method for finding the most well-connected, most agreed-upon blocks in the whole network. Imagine a storm of new blocks appearing every second. The K-cluster is the algorithm that finds the strong, stable backbone running right through the middle of all that noise. Now, to understand how it finds that backbone, we need to talk about a key idea, the anticone. I know, the name sounds super technical, but the concept is actually pretty simple. For any block you pick, its anticone is just all the other parallel blocks that it isn't directly connected to. Basically, it's a score for how isolated that block is. And this is the perfect way to think about it. It's kind of like a social network, right? A block with a small anticone is like a popular person who everyone knows and is connected to. It's right in the middle of the auction. But a block with a large anticone, that's like someone who's totally disconnected, with no friends or followers. It's just isolated. So the network uses this connectivity score to do something really, really important. It starts sorting. Every single new block gets put into one of two buckets. We call them blue and red. So the blue blocks are the popular ones, the well-connected ones. They have a tiny anticone, they get invited into the Clyde cluster, and they become part of the secure main chain. And then you have the red blocks. They're the poorly connected ones. Now, their transactions are still valid, that's important, but they're just considered too isolated to be used for the network's core security. So how does the sorting actually happen? Well, it follows this really clean four-step process. First, it takes the cluster that already exists, that's its foundation. Step 2, it grabs all the new blocks that are waiting to be checked. Then, for step 3, it tests every single one of those new blocks against the connection rules. And finally, step 4, if it passes, it's colored blue and joins the club. If it fails, it's colored red. That's pretty much the whole process.
But that brings up a really good question, right? What are these connection rules? This is where the K and K cluster finally comes into play. You can think of this K parameter as the rulebook that the whole security system follows. And it's dynamic. This K value is basically the bouncer at the door. It sets the maximum number of disconnected blocks, the max anticone size that a block is allowed to have. So when the network tests a new block, it checks, if we add this block, will it push itself or any of its new friends over that K limit? If the answer is yes, it fails the test. It becomes a red block. And here is the most genius part of the whole thing. K isn't just one fixed number. It adapts. I mean, look at this. When the network is moving slow at just 1 block per second, K is a pretty strict 18. But when things are flying at 100 blocks per second, the network gets more tolerant, and the K value skyrockets to over 1,000. The rules literally change with the network speed to keep everything secure. And here's the real kicker. That K value isn't just a random guess. It's mathematically calculated so that any honest block under normal conditions has a better than 99% chance of being accepted as blue. This whole design basically ensures that seeing a red block is a super rare event, a statistical anomaly, not something you see all the time. Okay, so we've been deep in the technical details, but let's pull back up. Why does any of this actually matter? What's the real-world impact here?
Well, first and foremost, you get insane speeds. The K-cluster is what allows the network to safely sort through tons of parallel blocks and figure out which ones to trust. It completely shatters that old one block at a time limitation that's held back so many other blockchains. Second, and this is absolutely crucial, you get mathematical security. This isn't just a theory that we hope works. It's backed by proofs. That adaptive K parameter gives you a statistical guarantee that security is maintained, even when the block rate goes through the roof. That's a level of trust you can actually build on.
And finally, the whole system is built to scale. It's future-proof. As technology gets better and networks get faster, the security model just adapts. It adjusts and keeps on going. It's designed from day one to handle pretty much any speed you can throw at it, which is incredible.
Which really just leaves us with one big, fascinating question. For so long, we've been told we have to choose between speed and security and decentralization. By creating a system that seems to achieve all of them, is the Transit Cluster the innovation that finally unlocks what blockchain can really do for our high-speed world?